So welcome to the voltmeter section, my dear friends, and now we are going to make the voltmeter after we have created the galvanometer itself. So first of all, congratulations because you learned to make an instrument by your own self with the very simplest of the things. Well, now it's time to level up and learn the voltmeter. Well, what a voltmeter actually do? This might be the first question that we need to address, that why we are studying the voltmeter itself comes first from what the voltmeter itself is. Well, voltmeter is an instrument. Well, it's an instrument that measures voltage across a circuit. Well, I'm not writing across a circuit, you can just understand that. Okay, if there is a series of the thing or so much of the things that is happening on the circuit, if you have a voltmeter in your hand, you just have to plug one at the one end and second and the other end, maybe the positive or negative end, you can call it as like that, but you can choose any 2 point. It's not necessarily be positive or negative, it will give you the answer for each case. So you are able to measure the voltage. Well, this is one of the most famous scientists name, whose name was Volt. Well, you can understand the voltage in the simple terms as in the form of energy. The electrical energy is also called as volt. In simple terms, you can understand that in this way. Not precisely it is energy, but kind of the energy, because so many electrons if go in one direction and leaving the nucleus of so many atoms at one side makes it dipolar in nature. So this dipolar nature brings the potential difference, and that is also known as voltage. Generally in our homes we use 220 or 240 volts, or sometime it varies whichever country or whichever region or area you are living in, but this is somewhat everyone is familiar about. Well, our chargers of cell phones are working on 15 volt, from 5 volt to 15 volt, or sometimes 25 volt, not more than that generally. If you're not having a very complicated cell phone, this is the power charge that we require for that. Okay, so we have studied that what is the voltmeter. It is an instrument that measures the voltage, and Volt invented this fantastic instrument. It is generally and simply means about the positive or negative dipole that comes in. The positive negative you can assume is at north and south type. If you are able to relate it from the magnets, you can also relate it with the magnets, whichever way you like. So this will going to give us the voltage, and from that voltage we can run our devices and other such things. It is required generally in home. This is the configuration that we usually get, 220 or 240 or 280 volts sometimes. Okay, so now let's make the voltmeter itself. Wow, that's interesting, right? I am very excited about this. Yes, now we are going to learn the second instrument, that is gonna be voltmeter. Okay, so are you ready, my dear friends? So let's make the voltmeter. Well, what if I tell you that we need a simple instrument called as resistance? Well, this is called as resistance. You can buy the resistance in the market, and this is the symbol for resistance. Well, technically it's a device is mostly cylindrical in shape and having different colors labeled on them that shows its configuration and numbers sometimes, and that will going to help us to put in our instruments. Well, resistance is everywhere. No matter which instrument you are using a resistance for sure. Well, so what the resistance is doing in the voltmeter? Well, we are going to learn a different way of making voltmeter. As I said, the galvanometer is the boss here. So we are going to learn the concept of voltmeter using the galvanometer. So imagine that we have galvanometer. I'm not making the entire galvanometer that we have learned right here, but I'm using a symbol for galvanometer by writing the G and bringing the two lines or two wires out of it. So this is the galvanometer. Well, that's how it seems actually, but obviously in simple world the things are smaller and more precise. That's why the companies and laboratories make these kind of things generally, and when we make it, sometimes a calibration problem occurs. Okay, so let's learn about the galvanometer. No, voltmeter. Yes, you are right. I'm not taking you to the galvanometer again. I am taking you to the voltmeter again. So what a voltmeter actually do? Well, first of all, we need to understand that what a voltmeter do. Then we can surely find easily that how to use a galvanometer in the form of voltmeter. Well, it wants to stop all the current. Imagine that you have put a barrier. If you use a barrier and imagine that the current is somewhat like going of electron or coming of the wave or whichever way you like it. So every wave is coming and hitting the surface again and again. When it is hitting the surface, what we actually get? We actually get the hitting numbers, right? If you imagine it clearly, you can imagine that. If you have ever gone to the beach or have seen the beach, the waves, the water waves hits the ground, and that's the exact same thing I am talking about in the instrument. If it all hits at one point, what we get is the number of electrons. Well, remember that I told you about this one, that is making the dipole is the separation actually. If the current is going, if the electron is going in this direction, they're going to get current in this direction. Well, if you know about these things, don't worry, we have a particular section for that all, which is going to be next section, that is about the electrical technology, where we will discuss precisely what is the current, voltage, electricity and everything. In this one, I decided to bring this topic up so that you get the excitement of this topic and we can actually learn some kind of the science that you can see, because in the Boolean algebra you can imagine, in the semiconductor you can imagine and maybe make or relate the things, but this is the thing that you can see, work and play with. So let's begin. So how we are going to make a voltmeter? Finally, yes, finally. So we just need a resistance that is called as shunt resistance. I'm just going to write that right now. Just wait for a while. And we put a galvanometer. Then we can use the battery or whichever power source that we like. That's it. That's all what we need. So this is the resistance of the galvanometer itself. I made it individually, but don't get confused. This is inside of it, okay? If I make it like this way and write it as galvanometer's resistance, so it might get confusing. That's why I made it outside of it. Okay. Now, this is called as RS or shunt resistance. So what a shunt resistance do? Shunt resistance actually helps us to calibrate or manipulate the value of resistance, means stopping of the current or electron, whichever way you like to call it. It is stopping. Resistance itself means stopping something. It is resisting the current. Okay, so in the ideal voltmeter, we need infinite resistance. Wow, infinite resistance. How you are going to and deciding to bring that infinity in the real world? Well, we cannot bring that to the real world. So in the real world, generally 100 or 200 or generally more than that is used as the value of shunt resistance for its purpose. Now, what actually happens? Imagine that all the current is stopping by here because of the high resistance. We are getting high number of hits here, so that hits getting a dipole of negative or positive charge, whichever way you like to call it, because it will not going to make any difference. The positive negative is just getting separated, and if you count one, you count both, because if one electron is here and it goes to this point of one electron, this will going to give us 1 unit of current or ampere, whichever way you like to call it. So these are pretty much the same. If you study the one, you already know the second one. Okay, so let's see that what happens. It hits again and again, that will going to make a dipole difference, and this is our device and in entirety. Well, you can remove this voltmeter or can place it. That's totally depends upon you. Generally we sometimes keep it, sometimes don't keep it. It's completely fine. Our meter technically is galvanometer, so this is our meter. And why making it happen, two words are very important in using these instruments. Either we place it in series or parallel. Well, when we make a galvanometer uh, converted into voltmeter, we make a voltmeter out of a galvanometer. So we need to make it in series. Well, what is the meaning of series? Well, very simple. If this is one resistance and this is one resistance, this is known as series. There's another thing that is called as parallel. Parallel simply means this is our resistance and this is our resistance, so this is known as parallel. Well, that's simple, right? R1, R2, and in this case, R1 and R2 also. So this is series and parallel. But this is all about the voltmeter, and this is going to help us understand that how a voltmeter actually works. I hope you can see and imagine by your imaginative eyes and can enter and sit down on the current and travel at the speed of light and can stop by the shunt resistance and can see that what the galvanometer is reflecting when you look back, and that meter is called as voltmeter, placed in series to check the things. Well, that's it for the voltmeter. In the next one, we are going to learn about the ammeter. Well, before ending this, let me tell you that the unit for used for voltmeter is V itself, like we say 5 volt or 10 volt, so we write capital V. And why I chose this one? Well, I want to tell you something which is incredibly interesting. Imagine there are 2 points that your voltmeter is attached with. This is our voltmeter. Now I'm making simple V so that we can understand the voltmeter itself. Well, voltmeter is actually the galvanometer's advanced form. Now you understand that that's just made with the resistance help, and it is showing us the voltage. That's it. So if we measure this kind of thing at 2 points precisely, if this is showing plus 5 volt and this is showing 15 volt or plus 15 volt, the actual thing that our voltmeter is going to show is 15 volt minus 5 volt, which is equal to 10 volt. So what we are able to see in our voltmeter is that 10 volt or 10 voltage. This is the amount of the voltage that is passing through these 2 points. Well, we can call it as A or B, from A point to B point. So that's why in the real life we don't use the word the potential itself. Engineers and scientists who are working on this, and as a student you have to use the word potential difference. The entire thing that runs is not running on the potential. Potential itself means static or at rest. You want motion. That motion helps us to make the disturbed equilibrium, or you can say movable equilibrium, so that we can keep the things rolling, and that rolling comes from the difference, and this is precisely the difference. That's why it is called as potential difference. I hope you have got my point, and now we will see the M meter in just a while, so stay tuned. God bless and take care.